Now finally we come to trapeziums. First thing about trapeziums is that it is not a parallelogram. Okay, that is the first thing. Second thing is only one pair of opposite sides, right? Because if both the pairs of opposite sides are parallel, only one pair of opposite sides are parallel. Okay, and not equal. Remember, we have already discussed in parallelograms that if the opposite sides are parallel and equal, it will be directly a parallelogram, right? If both the pairs of opposite sides are parallel, then also is a parallelogram. So in case of trapezium, opposite sides are parallel for only one pair. The other pair should be not parallel. Also, the parallel sides should not be equal. Okay, so if I take two sides like this, parallel and not equal, and join these two sides, it is a trapezium, right? So let's say ABCD is a trapezium. AB is parallel to CD. So all the properties related to parallel lines will be applicable here. For example, angle A plus angle D, that is equal to 180 degree, that is by virtue of parallel lines. Okay, angle B plus angle C, that is also equal to 180 degree. There is no direct connection between angle A and angle B. Okay, and the area of trapezium is calculated as sum of parallel sides. So if I take these two as parallel sides A and B, so sum of parallel sides by 2, that is actually average of parallel sides into the height. So here I am saying this length is the height h. Okay, so this is one part, this is one part. And then we come to the most important part, that is diagonals. Diagonals divide each other proportionally. Diagonals divide each other proportionally, okay, in the same ratio. In a way we can say that in same ratio, and that ratio not 1:1, because again if the diagonals divide each other in the ratio 1:1, it will again become a parallelogram, right? So diagonals divide each other proportionally, divide each other in the same ratio, but that ratio should not be 1:1. What does that mean? Let me draw the diagonal here. This is the diagonal AC and this is the diagonal BD. Suppose this is the point E. So what it means is, I'll write here, it means that AE is to EC, that is equal to BE is to ED, right? Also you can see that AB is parallel to CD, so triangle AEB will always be similar to triangle CED. If that happens, then A upon EC will be equal to B upon ED and it will be equal to AB upon CD, right? Okay, so that's the idea of this similarity of triangle in this case. So here triangle AEB and triangle CED, they will be similar. There is no connection between these two triangles. In a general trapezium, there is no connection. Okay, so this is one part of it. Using basic proportionality theorem, or anyways, you can see that here ratio of area of triangle AEB upon area of triangle AED, right? It is equal to BE upon ED, which is equal to AE upon EC, and AE upon EC should be equal to area of triangle AEB upon area of triangle BEC, right? Oh, so what do you see now? Can you compare this ratio and this ratio? It means always area of triangle AED will be equal to area of triangle BEC. There are any other ways also, but yeah, this is how you can remember. So areas of these two triangles will always be equal, whatever is the type of trapezium. Fine, so there are many questions that you can identify. One more thing that I would like to mention here, if I say the height of the upper part is h1, height of the lower part is h2, okay, then this ratio AE upon EC equal to B upon ED equal to AB upon CD, this is further equal to h1 upon h2, right? So this can be used in division of areas also. Now here, can you draw a circumcircle? Not always, not necessary. Okay. Can you draw an incircle? Again, it will be conditional. So in case of trapezium, there is no direct relation or information about circumcircle and incircle. So I would say simply not necessary. Now there is one specific situation for trapezium, and that is called isosceles trapezium. Now what do you mean by isosceles trapezium? You see, in case of isosceles trapezium, the non-parallel sides are equal. So in a trapezium, if non-parallel sides are equal, then non-parallel, you have to understand that parallel sides anyways can't be equal. So if the non-parallel sides are equal, it is called an isosceles trapezium. So I'll just try to draw as correct as possible. So here what we are saying is ABCD. AB is parallel to CD, AB is not equal to CD. And this AD is equal to BC. These are the non-parallel sides and they should be equal. Then this thing ABCD is called an isosceles trapezium. So all the properties of trapezium will be applicable to isosceles trapezium also. All properties of trapezium will be applicable here also. One extra property will be diagonals equal. Very simply, diagonals equal, as simple as that. Okay. So here in this case, this AC will be equal to BD. Now what do you get from there? You get isosceles triangles. What isosceles triangles? If AC is equal to BD and the ratios are equal, then what it means is, you see here, if I say this point is E, then AE will become equal to BE. Okay. CE will become equal to DE. Right. Here then triangle AED will become exactly same, congruent as triangle BEC. Okay, these two triangles will become congruent, right? Congruent. Rest of the things will remain same as we have from the trapezium properties. One important thing that will come here in this case extra is that in case of isosceles trapezium, can you draw a circumcircle? Yes. Because you see, yes, we can draw. But the other things, other information related to that circle, that we will have to find out. We will not have a direct formula for length of circumradius, because the other things should be given. But we can draw a circumcircle. The reason is that I'll explain here. I'll use another thing here. Cyclic quadrilateral. Now cyclic quadrilateral is not a type of quadrilaterals. Okay, it is a property of quadrilaterals of being cyclic. What does that mean? If I can draw a circle passing through all four vertices, circle through all four vertices, right? Then that quadrilateral is called cyclic. That is the meaning of cyclic word. Okay. And how to check? It's very simple to check. If sum of opposite angles is equal to 180 degree, as simple as that. See, we already know that sum of all four angles of a quadrilateral is 360 degree. Now, if sum of one pair of opposite angles is 180, then automatically the other pair is also 180. So we only need to check one pair. The other pair is automatically 180 if one pair is 180, because total has to be 360. So the only way to check the cyclicity of a quadrilateral, or being able to have a circle. Cyclic quadrilateral means a quadrilateral that has circumcircle. Okay. And one simple way to check that is sum of opposite angles should be 180 degree. So which all quadrilaterals are automatically cyclic? By default cyclic. By default cyclic would be, I think you must have seen by now, by default a rectangle is a cyclic quadrilateral. Okay, square is a cyclic quadrilateral. So in a way I can also say that if a parallelogram is cyclic, then it must be rectangle. Hear it properly. If a parallelogram is cyclic, that means it has to be rectangle. Okay, square is automatically cyclic. So if I say a rhombus is cyclic, that means it has to be a square. It doesn't have any other option. Fine. And this isosceles trapezium. this also is, isosceles trapezium is also by default a cyclic quadrilateral. How come? I'll come back to this isosceles trapezium here. You see, if AD is equal to BC, then there are certain extra information that will come here. Angle A will become angle B equal to angle B. Angle D will become equal to angle C, right? And we already know from trapezium that angle A plus angle D is equal to 180 degree. That is from trapezium, from parallel lines. And here we have D equal to C. So clearly angle A plus angle C will also be 180. And hence angle B plus angle D will also be 180 degree. Oh, great. So this also becomes cyclic. That means we should be able to draw a circle, right? Like this. Fine. So by default, these three are cyclic quadrilateral, rectangle, square and isosceles trapezium. Okay. And others may or may not be depending upon this condition. And as far as area of isosceles trapezium is concerned, you don't need to worry about derivation of a new formula. Calculate in the same manner as we did for trapezium, that is sum of parallel sides divided by 2, or the average of parallel sides into the height. Though you can calculate the height, if the length of parallel sides are given. You can drop a perpendicular here, you can drop a perpendicular here. You can get, these two lengths will be equal if you drop a perpendicular in case of isosceles trapezium. Then you can use the Pythagoras theorem and find the height. Okay.